And so this is going to be, as I mentioned earlier, a presentation by one of our core design partners. And so if you're interested in becoming a design partner, please go to the Flower website and look at our pilot program set of pages. It details an application process whereby Flower and different organizations can work together to accelerate our mission and develop new methods or new applications on the Flower platform. And so one of our early adopters and participants in this program has been Kang-Yoon Lee, Professor Kang-Yoon Lee, who leads the Cognitive Computing Lab in Korea at Gachon University. And he has brought a number of his team members along today to tell us all about a platform they've been developing that focuses on federated learning management of what is often a complicated marriage between machine learning and distributed systems. And so I'm delighted to see the work they've been doing, and I'm really happy to see them sharing their progress with us today. So I'll hand over to Kang-Yoon so he can start their presentation.
Okay, thank you. So I'm sharing. Okay, thanks for giving us our monthly presentation and also the kind explanation about the Gachon University's design partner operations. So we are developing FedOps on top of Flower framework, and today I will deliver the FedOps the tutorials and our communities. So I will explain FedOps, the overview I'll cover, and FedOps silo and FedOps mobile. The tutorial will be delivered today. Yonggyum and Pao, who are master students, will join to deliver tutorial session as a hands-on lab. Through this session, it makes you to learn FedOps with your AI model and data. So the FedOps motivate to operate and manage federated learning environment such as machine learning MLOps of AI model. FedOps has three key questions. Question one is how can the machine learning project be easily applied to distributed federated learning environment? Question two, there are numerous clients. How can we distribute models and data on federated learning environment? And question three, how can you manage and monitor the lifecycle of client and server for federated learning operations? Right side, the picture is an overview of FedOps. We expanded the existing MLOps to easily apply federated learning to machine learning project. The baseline model created through MLOps is deployed and executed to numerous clients so that federated learning can be performed by connecting to the server. FedOps supports that local global models can continuously manage the version. And FedOps can manage and monitor the federated learning lifecycle by tracking the logs of clients and server for federated learning operations. So to solve these three questions, we need to provide FedOps with 5 core functions. First, FL Scalize. The meaning of FL Scalize is that the data and models can easily apply to a federated learning environment. FL Scalize utilize Flower framework to scalize FL client and server. FedOps is configured by applying to the Flower code structures. Second, FedOps has client-server manager functions. Managers continuously manage online training status of client and servers. The third one is CE and CS function to improve the performance of federated learning. Contribution evaluation and client selection are performed according to the client's performance. We will consider many algorithms for client selections. Fourth, CI/CD CFL is connected to code repo to deploy code to numerous client and servers and perform federated learning continuously and periodically. We use GitHub for code repository. Fifth, FedOps has client and server monitoring dashboard for lifecycle management of federated learning client and server. We are using 1DB, ELK, and FedOps Web. And it shows FedOps open source community as same as Flower community. There are web links for FedOps main site, GitHub, and document. So please report all this information. You can clone a Git and learn as your own purpose. Okay, now we will have FedOps silo and mobile tutorial session to show how you can utilize Flower and FedOps. Yonggyum, will you explain more about FedOps community site and lead FedOps silo tutorial hands-on lab?
Yes, Professor. Hello, my name is Yonggyung, and in CCL, I develop FedOps Web and FedOps Silo site. Okay, let me explain FedOps community. First of all, our FedOps Web. This is our FedOps Web main page, and in here you can create and manage the task for conducting federated learning like this on this page. And FedOps document. In here we describe FedOps architecture and user guide and our libraries function. So if you have any more detailed information, please watch this our documentation and our FedOps GitHub. Our FedOps are open for everyone, so you can view and modify the source code, and it also provides a link can be accessed with Slack and LinkedIn and our CCL site. So you can access the communities you want. And also we present at Flower Summit 2023, and it is posted on the YouTube. So if you want to watch it to our presentation, please use this link and watch our presentation. And last one, we make the Slack for FedOps. So if you have any questions or improvements for FedOps, please tell us through Slack and we will solve to you. Let's start the silo tutorial now. The FedOps silo consists of 5 steps. The first Apple test create and measurement step is to create FedOps baseline code and create the data and models for federated learning. And second, register Apple client. Client just bring and execute the previously written baseline code for your Apple test. And third, select client and run Apple test. In here, you can select clients who will participate in the federated learning and start the federated learning in this step. And fourth step is check the client log during the federated learning. You can check the client learning situation and the server status. And the last step is monitor the global model of task. It is when the federated learning is ended. And you can check the client, and also you can download your the global model on your FL test. To perform the first step, we should go to our FedOps main page. and click this FedOps silo, then you can download our FedOps silo baseline code. You just bring this to your own development environment like this. You just modify models.py and data preparation.py. The others are not modified. The others not use. The others just run as automatically, so you don't need to modify them. In the models.py, put your model you want to run in here. I set MNIST classifier as a model, and I said how to train and how to test. And in data preparation file, you just coding for your data, like pre-processing or split into train and test dataset. And in here, I use the MNIST data and the split into test and train. After that, setting the configure file. In here, you select your models, which model is using library. We are using PyTorch, and model's name and dataset name. And in here, this is for the server's configuration. We set epochs as 3. Batch size is 100-28, and our ROM round are set 3. And you can set also clients per round. And in here, you just set server strategy. Are we using bad averaging as a strategy? You finish, modify the configuration, and just push to your own GitHub links. I push the baseline code to my Git repository, and after that, we create the FR test. In here, make the task's name. I say flower monthly silo, and select client type and set the description about the task. And in here, a server Git repository address is your Git repository. Your server baseline code is store the repository like this. Copy your link and paste it here. And click the create. If you see this page, the task is successfully created. And the next step, client register page. Each client cloning this baseline code to each client and set here task ID to your task name as you created. In here, my task ID is flower monthly silo. So copy task ID and paste it here. This is for the client to notify to server. I want to participate in this task. So I set the task name as a task ID, and client just run Python file client main.py and just run client main.py. Then client main will be communicate with FL server for Federated running, and client manager will communicate the server with the FL server status, and client manager notify to server or client status. So back to our FedOps web, then this we can watch which client is ready for Federated running. So you just select your client and click FL start. Then FL Federated running is ready for start. And until it is running, I will show you the FL test, our silo tutorials results, monitoring and global model. Go to your task as you want and go monitoring tab. In here, you can see the global model performance like this. And also you can see each client's performance and resource usage. And also change the model's version. So you can see each version's global models too, and each version's clients too. And in global model tab, you can download each versions of global model, so you can using the global model or you want. And by as a final, we can also check the client log. In client major, show the health check with client and server. It said April is ready for because it was because our client is running in this time, and client main the pie show the log of the client's running status and performance like here. This is the end of Silos tutorial, and I will turn over to Hahoud for our FedOps mobile tutorial. Hahoud, please tell us your tutorial.
Hello everyone, is it visible?
Yes.
Yes, looks good.
So I'm Farhud, I'm a member of Social Laboratory, and currently I'm developing FedOps mobile part. And today I'm going to give you FedOps mobile tutorial. So let's start from first FedOps mobile architecture and overall overview. So FedOps mobile based on iOS and Android platforms on top of Flutter. So Flutter is open source SDK provided by Google. So with Flutter, we can develop multi-platform applications with same code base. So in FedOps also we used native platform functions using event channels and method channels. We can call Android and iOS on training features, on device training features using these methods. We can call one-time call functions using method channel, and we can listen continuously methods using event channel. So I will move to today's tutorial. For this demo, we used Cypher 10 dataset for Android, and for iOS, we used MNIST. So first you have to create your model using TensorFlow and convert to TensorFlow Lite format using for Android, and for iOS, you have to create your model using Core ML create app using Xcode. And once you create your models and convert, you can see your core TF Lite model description like this in this picture, input details and output details. And for core ML model, you can open using Xcode and see the descriptions as in the picture. So to use FedOps mobile, you have to clone FedOps mobile from here and open FedOps mobile in your Android Studio. And to implement your model, open Android folder in the project and open app. And here we have build Gradle file and put your model URL at here and data URL to here. Your URL should be downloadable link. Just download when you click. And for the iOS, open the iOS folder, put your model and dataset inside the scenarios folder in here, like MNIST, and these are train and test datasets. And this is our core ML model. So to develop, first you have to implement API connection parts because we get our server link ports through the API from our server. So it's just basic things. I'm not going to explain this. For your development page, you have to implement download dataset buttons and connect server and start training buttons. You have to connect these buttons to UI. And once you run this demo, you will see this view. And then you have to create your task from our FedOps website. To create, login to FedOps website and click the create button and enter your task name. I'm going to enter it as tutorial monthly. And for this tutorial, I'm going to show Android. And for description, and here you have to input your Git repository link for your server. For my server repository link, I'm using this repo. You can clone and use in your Git repository. And first, you have to edit this file for your configuration. In our configuration, I'm using Android, and we have 5 number of efforts, and batch size is 10, and our number of rounds is 3, and at least one client should have for each round. I will copy the link, enter here, and I will create my task, and enter here your task name. So our client is registered. You can see here each client's identifier in these numbers, and in mobile it will be here. And we start our server for this client. Usually it takes 1 to 2 minutes for it's running. So I already created other task and it's already running. So we don't need to wait for this task. So I will use this one for rest of the tutorial. The task name was demo task. Yeah, so our device is registered here. So it's already started and running. Then we can get our server port by entering the task name again. So server creates this port for our task, and this is our task ID. So we start loading the dataset. In console, you can see our client starts loading dataset and it's already finished, and we can connect. So our client is connected to server and we can start training. So our client is already started, and you can see here current round and epoch. After each epoch, you can see accuracy loss, and in this progress indicator, you can see how much of the overall progress is done, and in this chart, you can see your accuracy and losses as chart format, and in console, you can see other console messages. For implementing machine learning models in mobile, it's really difficult task. We implementing other custom datasets and models. Upcoming months, we will show how to implement and create custom models for mobiles, and we will provide other public datasets to choose while you're training. Yeah, so our training is finished, 3 rounds and 5 epochs. Here you can see your client's overall results. And for platform, for now, monitoring your clients from web is not possible, but we also developing this part. In upcoming versions, we will provide monitoring clients in FedOps platform and see global models from here. But for now, only monitoring client in mobile side is possible. So that's all for mobile tutorial. So I will move to Professor Lee. He will cover up the rest of the presentation.
Okay. So thanks for the presentations. So we deliver the FedOps Silo and FedOps Mobile, how we can easily build federated learning environment on top of Flower. So now we announce special program to support as user trial program in January. So if you use FedOps, just you can fill out the information as on the right side and email us. Then FedOps team will support you with your federated learning scenarios. So let's make the many use cases. And in addition, we are currently creating FedOps industry fact as a reference use cases. So it would be a good reference to apply your model to FedOps in the world. So it is end of the presentation. Thanks for listening. I would appreciate your questions and suggestions on FedOps and these tutorials.
Thank you for the 3 presentations. They were like really informative, and I think they give the community a snapshot as to what the system is able to offer. I'll take a look to see if there's any questions. Feel free, anyone who wants to ask, they can use the Zoom or the Slack or anything. But as the talks were going, I was collecting a few of the questions that came in. And the first of these was, I guess you've answered at the end there, but one of the questions that took my attention was, they said, can they use it today? I noticed at the end you said there was a sign-up process. Could you tell us a little bit more? If somebody wants to use it today, should they just contact you using the method you described?
Yes, Yonggyum, will you explain about how we sign on to FedOps site?
Oh yeah, in now we block for the register the account. So if you want to make an account and using our Fedora, please send the email from like appropriate set. Then we will make the account and send back to the account we create. So yeah, in this time, please come our FedOps participate.
I see. And so that can be from it can be any application domain. So at the end there was hospitals mentioned, but you're open to any type of application that someone wants to use the system for.
Actually,
In this
the AI
time,
model and data, if they bring us, then we can build up on FedOps environment.
Great. So it could be any application domain. Then it sounds like
Yes.
anyone. Yeah. Perfect. Very good. Another question somebody had was what is the biggest thing that you think becomes easier with the system? I noticed there was web GUI things, there was monitoring of clients and so on. Do you want to perhaps, I think an interpretation of the question would be, could you pick out what type of usage is the thing that people might get the biggest benefit from?
yeah, I think our FedOps biggest approach is it's easily implement to real world. Uh, we just only make the baseline code for server and client, and server and client just running the baseline code at once, so you did easily communicate with a real device and server. And in our industry pack, we are planning uh, about 100 hospitals emergency rooms as a client. So we are testing it.
Sounds amazing. Sounds like 100 hospitals would be incredibly impressive deployment. I guess another question relates to limitations. Are there any specific limitations that you want to point out to people at this time? I understand you're just developing it and onboarding some initial users. Are there any particular limits, maybe with the type of model, or I don't know, anything at all you want to highlight?
In this time, actually, our server resource limitation. So we maximum 40 FL server will run at same time. So uh we get the participate for this limitation. And the next limitation is at this time we are more good at only classification models, and the others are not well worked in now. And also, we just only see the client logs, not server's logs, because so we develop this part for the in FedOps web. Users can watch the server's log and how server running going and how server status is, and any other problem is occurred in server to watch the user.
I see. See, you mentioned a limit of 40. Is that 40 aggregation servers running,
Yes,
or is that
aggregation
40?
server.
Oh, okay, 40 aggregation servers. So that would, roughly correspond to 40 different federations then, depending on what the topology.
Yeah.
I see. Okay, cool. I guess my own question would be, what do you see happening next? Like, what does the next, say, 2 months look like for this really strong application and system?
Oh, within 2 months. Okay. So next, our consideration is we need to have more the class selection algorithms, and also the integrate with the public cloud models. That's the primary agenda, and we need to get a requirement, and then we can make further.
I see. Great. Great. Well, thank you so much. I'm super impressed by what you've been able to accomplish, and we're delighted to have helped you in a very small way wherever needed. But it's really amazing what your team has accomplished here, and I hope that many people from the community utilize these capabilities. Wonderful stuff. Thank you for the contribution.
Thank you for the opportunity.